Hello and welcome to section 2.2. This is basic differentiation rules and rates of change. What I would like to talk about is basically we hopefully have learned the shortcut from the previous section, and if we haven't, we can still go through all of that. But what we know is that if we take the derivative of a constant, we end up getting 0. So if I could write the derivative of a as dy over dx of 7, well, that will equal, well, actually, this will just equal 0. So that's for a. If I want for b, I could say f prime of 0 of x, which is 0, will also equal 0. If we say for c, if we say s prime of t, well, that's of -3, that's also 0. Because you got to think about what we're talking about when we're dealing with this is that we're asking you for what is the slope of the tangent line along that function. And you just got to remember what these functions look like. They're horizontal lines, so the slope is 0. And then if k is constant and pi squared is constant, this is the same thing. I'm going to write it as dy dx, and that also equals 0. So whenever you have a horizontal line, you're going to end up with a slope of a horizontal line of 0. So, well, now we get a little bit of a shortcut for what we've done, and this is what we're using the power rule, and hopefully you figured that out from the notes. And basically what the power rule says, if we're going to find the derivative of this, I could say, well, f prime of x, and what we do is we multiply the function by the power, and then we reduce the power by 1, which gives me 2. So then, for part B, when I go ahead and do this, I'm going to rewrite this as g of x to the 1/3 power. It'll just make things a little bit easier. So when I go ahead and take the derivative of this, I'm going to multiply by the 1/3, which gives me 1/3 x, and then I got to reduce this by 1. So when I subtract 1 from it, I get a -2/3. So we don't like to leave our answer that way, but eventually you'll get used to it. But my final answer for this is going to be written as 1/3x to the 2/3 power. And so that's basically what I'm looking at for my derivative. And remember, these are slopes of tangent lines. This is our slope machine. This is our function that will give us the slope at any given point along that line. And so then, if for this one, I'm going to write this as, if I'm going to take the derivative, it's going to be dy dx. But first, I'm going to rewrite this since it's 1/x squared. I'm going to write it as x to the -2. Same thing, but it just is a little bit better. It helps our power rule. And so when I take the derivative of this, I put the old power out front and reduce the power by 1. So be careful on this, because when we reduce the power by 1, it's not -1, it's -3. So my final answer for this one can be written as -2/x to the 3rd power. And so that's what we're looking for when we go ahead and do these functions. So moving on to the next example, it says find the slope of the graph of this function at these points. Alright, so if we're going to do that, I'm going to take the derivative of the function using my power rule, which tells me to take 4x to the 3rd. And now, if I want the derivative of 1, I'm just going to plug, or of -1, I'm just going to plug -1 into this function, which gives me 4 times -1 cubed, which simplified is -4. So that's the slope. It's a downward slope. And so then if I want 0, f prime of 0, well, I plug 0 into this function, which gives me 4 times 0 cubed, which just will give me 0, so it's a horizontal line. And remember, always pay attention to these horizontal lines. That's basically what a lot of the things we're going to look for in the future. And so now if I put 1 in, it's going to be 4 times 1 cubed, and when I simplify that, I get 4. Well, this may or may not make sense to you, but when you're looking at the graph of x to the 4th, remember it's kind of a W-shaped graph. Looks something like that. And at 1, I'm looking at a point somewhere over here that would be at -1. It would be a -4 slope. Over here would be my 0 slope if it was in the middle, and then up here somewhere is my 1 slope. And so that's kind of what we're looking at. And so if you draw the graph, and the original graph, and kind of think about what's happening around those points, it is kind of helpful to see what's going on there. So now we're asked to find the equation of the tangent line to the graph of this function. So, well, there are 3 things that we need when we're asked to write the equation of the tangent line. We need to find slope, and we need to find an x point and a y point, which is an ordered pair. And so I have those. So those are the things that I need to write my equation, my tangent line, because I'm going to use point slope. And when I do that, I need an ordered pair, my x1, y1, that'll be these guys right here. And then my slope is the m value down there. So that's really what I'm looking for. And so I'm going to go ahead and and the way I find the slope is by doing the derivative. In this case, though, since I've got -2, I could plug -2 just into the function. And remember, the f of x is really the y value. So if I put f of -2 in there, that will give me -2 squared, which is really 4. So now I have my ordered pair, my x1 and y1, so I could start writing this out and say y minus 4 will equal, I'm going to skip the slope for the time being, x minus, and it was -2, so it becomes add 2. And so now we're going to find the slope at -2. And so I got to take the derivative. I got to do my calculus part. And so I go f prime of x. And remember, we always take the derivative in general before we plug in the value. Because if you plug in the value, you're going to get 4, and then you're going to take the derivative of 4, which is really 0. So we do the derivative first in general, which gives me 2x. Remember, the power is 1, reduced x squared to 1. And so now this is my equation of my slope at any given point along x squared. And so when I do f prime of -2, I get 2 times -2, which is really -4. So there's my slope. And so that can go in right here. And so you don't need to simplify this for the AP test or for my class. So this is an okay equation. Y minus 4 equals -4x plus 2 for that. The only thing you might want to simplify it for is just in case on a multiple choice question that they simplify it. So moving on to the next example, we can go ahead and find the derivative of each of these functions, and these are just kind of special cases. And so if I go ahead and do that, well, again, we need to rewrite this one, and that's going to be the trick to these guys, is rewriting them is going to be the most important thing. And so you're just going to have to get used to this. I'm going to rewrite this as y equals 2x to the -1. So now when I take the derivative dy dx, that will give me, well, I multiply by the power, which gives me -2x, and then when I reduce the power by 1, it's -2. So my final answer for this, my final derivative, my slope at any given point, is really -2 over x squared. And that's really what I'm looking for. And you'll start seeing some patterns as you do these, if you do these more often. This guy, I can rewrite it as f of t equals, and probably 4/5 t squared. And this 4/5 is a constant multiple, so if you remember from what we learned earlier, that the constant multiples, we can just kind of leave them out to the side, and we're going to do the power rule on just the values. So if I go ahead and do that, I'm going to write this as f prime of t will equal, I'm going to leave the 4/5 alone for the time being, and following my power rule, I'm going to multiply by 2t and reduce the power squared by 1 gives me 1, so I'm not going to write it. And so I get something that looks like this. So my final derivative is going to be, well, when I multiply 4 by 2, remember this is 2 over 1, so I end up with 8 over 5 t. And that's my final answer for my derivative of that function. This guy, I don't like writing them as square roots, so I'm going to write it as a power. And remember, all roots are a power with whatever the index is on the bottom of the fraction. So this is a square root, which means it's a 2. So it would write it as 1/2. So now, if I want to find the derivative, I'm going to write it as dy dx equals, leave the 2 alone, that's a constant multiple. Now, following my power rule, I'm going to multiply by the 1/2 and reduce the power by 1. And so taking away 1 from 1/2 gives me a -1/2. And so now it's just a matter of simplifying this. And so dy dx will equal, well, 1/2 times 2 is 1, so that goes away, so I'm going to put 1. And since this is a -1/2, it's on the bottom, and you could write this as -1/2, that's fine, or same thing, square root of x on the bottom. And then this final one is a fraction already, so writing it as it is, it's 1 over 2 times the cube root of x squared. And I know that's a little bit tricky to see, But, oh, there's another one down there. Okay, 2 times the cube root of x squared, but that's really what I was trying to get at. This thing is supposed to be the index, not the power of on 2. So if I go ahead and simplify, if I go ahead and rewrite this, I'm going to say y equals 1/2. And now remember what happens when we're talking about powers down here. The cube root is on the bottom of the fraction, which would be 3, and then anything we take it to the power of goes on top, and since this thing's on the bottom, it's a negative. So now, if I go ahead and follow my power rule on this and take the derivative, dy dx will equal, I'm going to leave the 1/2 alone, and now I'm going to take the negative 2/3 and multiply by it. So negative 2/3, and then x, and then I'm going to reduce this by 1, so I subtract 1, and I'm not going to get 1/3. I'm going to basically add 3, so I end up with negative 5/3 for that one. And so my final answer, my dy dx, well, when I multiply these guys together, I get negative 1/3. And so the 3 is on the bottom, and since this is a negative 5/3, I'm going to write this as x to the 5/3, and that's fine. You don't have to simplify that anymore. And then my final one down here, I'm going to write it as y equals negative 3/2 x, since the x is on top. And so now I can just go ahead and follow my power rule, and so dy dx will equal, well, negative 3/2, and when I reduce this power by 1, or multiply by the power, which is 1, and then it becomes x to the 0 power, and when you do x to the 0 power, that's really 1, so it's 1 times 1, so my final answer is negative 3/2 for the derivative of that function. Now we could plug values into this and whatnot, and if we wanted to find them for all these functions and find out what the slope was doing. So thank you for listening today, and part B will be coming up soon.